Mars is venting methane again. Sharp, inexplicable bursts measured by Curiosity in 2025, matching levels unseen since the earliest days of exploration. At the very same moment, 3On I/Atlas, a volatile interstellar visitor, is hurtling toward Mars's orbit, radiating a green glow and outgassing hundreds of millions of kilometers from the Sun, baffling astronomers worldwide. NASA has never seen both alien chemistry and Martian methane spike in lockstep before. Is this a cosmic coincidence or the first evidence that something from outside our solar system is reshaping a neighboring planet in real time? The stakes for the search for Martian life and our own place in the universe have never been higher. June 2013, Gale Crater. Curiosity's sample analysis at Mars Instrument records a sudden surge. Methane levels jump from a background near 0.4 parts per billion to 6 parts per billion overnight. The rover's science team, led by Ashwin Vasavada, checks and rechecks the data. Instrument logs show no anomalies, no calibration errors. The spike is real. The next day, the European Space Agency's Mars Express orbiter passes overhead. Its planetary Fourier spectrometer detects methane 2, about 15 parts per billion, spread across 49,000 square kilometers. For the first time, 2 independent missions confirm a localized burst. The plume fades within days, leaving no trace for orbiters circling later. No global rise, no lingering signature, just a fleeting exhalation confined to Gale Crater. The methane vanishes as quickly as it appeared, setting off years of debate. Is Mars leaking gas from the ground, or is something destroying it before it can spread? By mid-2025, the methane story on Mars grows stranger. Curiosity's detectors, tuned for the faintest trace, report a new surge. Readings climb to 21 parts per billion, the highest yet recorded at Gale Crater. But the ExoMars Trace Gas Orbiter, circling overhead, sets its limit at less than 50 parts per trillion. That's a difference of nearly 400-fold, with TGO's sensors registering nothing, not even a hint during the same weeks. The surface is breathing methane. The sky, apparently, is not. Ashwin Vasavada, leading the Curiosity science team, calls it a story with a lot of plot twists. Engineering logs from both missions show no errors, no calibration faults. The instruments are working as designed. The gap between surface and orbital data is widening, and with each spike, the urgency for answers grows. Something on Mars defies easy explanation. In early 2024, telescopes worldwide flagged an object on a hyperbolic path, 3I/Atlas, the third interstellar visitor ever confirmed. Unlike its predecessors, this comet drew attention for a different reason: activity at a distance where sunlight is weak, nearly 6.4 astronomical units from the Sun. NASA's TESS, designed to scan for exoplanets, caught the first hints: a faint, persistent glow, then a sudden brightening. Photometry revealed a green-tinged coma, a sign of diatomic carbon, and irregular pulses in brightness that defied standard comet models. The TESS operations team logged each fluctuation, noting that the object's coma expanded even as it remained far from the inner solar system. By late spring, ground-based observatories confirmed the anomaly. 3I/Atlas was shedding gas and dust at a rate more typical of comets much closer to the Sun. Its unpredictable outbursts and vivid colour set it apart from both Oumuamua and Borisov, raising new questions about what interstellar comets might carry, and how they behave when crossing into our neighbourhood. May 2025. Data streams from Mars and deep space converge in a way that rattles mission control. Curiosity logs its highest methane spike to date, 21 parts per billion, just as ground telescopes and NASA's TESS report a dramatic outburst from 3I/Atlas. The comet's coma brightens and pulses, recorded by TESS photometry and confirmed by observatories in Chile and Hawaii. Within hours, urgent messages ripple through the Mars mission network. The ExoMars Trace Gas Orbiter, MAVEN, and Mars Express switch to high-cadence atmospheric scans. JWST, scheduled for a deep field survey, is redirected in a 48-hour emergency campaign to monitor the comet's volatile cloud. Slack channels fill with time-stamped logs, methane readings, dust influx alerts, comet brightness curves. For the first time, methane surges and cometary activity overlap almost to the hour. The coincidence is too sharp to ignore. Scientists debate in real time, are these truly separate mysteries or signs of a deeper connection? Avi Loeb, known for his bold ideas at Harvard, has floated a provocative hypothesis that dust from 3I/Atlas could trigger methane release on Mars. The idea draws from established chemistry. Certain minerals, when delivered by comet dust, might act as catalysts once they settle on Martian soil. In theory, iron-rich grains or exotic organics from an interstellar comet could interact with sunlight or Martian salts, breaking chemical bonds and freeing methane trapped beneath the surface. While no peer-reviewed paper details Loeb's mechanism, the concept echoes broader research on dust-driven catalysis and energy transfer. The possibility is tantalizing, but the evidence remains circumstantial. Skepticism runs deep. Neil deGrasse. Tyson warns against chasing patterns without proof, reminding panels that correlation is not causation. Mikio Kaku urges restraint. Extraordinary claims demand extraordinary evidence. ESA and NASA, in a joint statement, call the current overlap unprecedented but not fully understood. Officially, the agencies commit to round-the-clock monitoring, leaving the question open and the scientific world on alert. In 2013, NASA's Curiosity rover measured a methane spike of 21 parts per billion in Gale Crater, a result confirmed by the European Space Agency's Mars Express orbiter. Yet, the Trace Gas Orbiter has repeatedly set upper limits near 50 parts per trillion, often finding no methane at all. In 2025, Curiosity again detected a surge just as the interstellar object 3I/Atlas, discovered in 2024 and already active at 6.4 astronomical units, crossed Mars's orbital path. Despite coordinated emergency observations and mounting expert debate, no direct evidence links the comet's dust to Martian methane bursts. Scientific panels from the European Space Agency and NASA still label these events as unprecedented and not fully understood. The cause of Mars's methane spikes, geological, biological, or exogenic, remains unresolved. What is clear, Mars continues to surprise. 3I/Atlas's influence is under close scrutiny, and the search for answers now spans two worlds and interstellar space.